All right, I'm going to explain to you how to find average velocity when you have a motion with constant acceleration. I asked you today whether looking at a graph for that changing acceleration, which was right here. So when we looked at it, we could figure out our average acceleration, but not average velocity. The reason for it is that my acceleration is constantly changing. It was positive, 0, negative, 0, negative again, positive, slowing down, speeding up, all kinds of things were happening. However, if I know a section, for example, right here, this section right here, this definitely means that my acceleration is constant. It's a straight line. So for that segment, I could figure out my average velocity, and I'm going to explain to you how it's done. So if my object is moving with constant acceleration, this is what it looks like, because I know my slope is not changing, it's a straight line, and I also can see that my velocity changed from initial to final, right there. How do I find displacement? The very old formula for displacement comes from this. We know that average velocity is displacement over time. In this graph, I don't know displacement though. I have the time. I can see that this right here is my period of time that elapsed while my velocity changed from initial to final. Initial is 0, so from 0 to final, my velocity changed over this period of time. So if I knew my average velocity for this period of time, I could figure out my displacement, right? And then from calculus, maybe some of you know that the area under this graph right here represents, like here I have velocity, right here I have time. So ultimately, times velocity, anyway, velocity multiplied by time gives me displacement. And area under this graph is indeed the displacement that my object went through while it was accelerating from here to here over this period of time. All right, so how do you find the area of a triangle? Geometry buffs. We have base times half the height. That would be the area of this triangle right here. So here's the thing. Half the height, if this is 0, then half the height is half of my final velocity. But if my velocity initial is 0, I can actually add it, because if it's a 0, I can add it all I want, because it's not going to change anything. This right here is 0, so final plus 0 doesn't change anything. So this right here is my half the height. This is my base. Half the height times base gives me the area of a triangle. Look back over here. This is our very old formula. Displacement equals average velocity times time. Compare displacement, displacement. Time, time. Which makes my average velocity half of the sum of these two divided by 2. So basically, if you look at it, it's algebraic average of two velocities. And remember, at the very beginning I told you never take one velocity plus another and average them if you're finding average velocity. You have to go over the total displacement over total time. Indeed, this formula right here, will only work for the case when your acceleration is constant. And here's why. So basically what I'm saying is, if my average velocity is this, half of my 0 plus final, it brings me over here, right? That's my half. That is my average velocity. And then, again, if I take my average velocity over here, which is right there, let me bring the pen. All right, so this right here is my, oh, that's beautiful, average velocity. And then this right here is my time. So that's delta t. So if that's v times time, then this right here, this whole thing, the area of this rectangle will be my displacement. And indeed, average velocity times time equals my average displacement, right? Now, look at this triangle and this triangle. They're congruent. Therefore, their areas are the same. So if I take this area and add to here, it would be the area of this rectangle. The area of this rectangle is average velocity times time. The area of this triangle is also average velocity times time. So here's your formula for average velocity. Average velocity will be initial velocity plus final velocity divided by 2. So that is how you figure out average velocity, only for the period where your acceleration was constant. So if you know that your increase in velocity was constant during the same amount of time, that means that your average velocity, you take your initial plus your final and half it. Initial plus final over 2. Average. It's like algebraic average. So then, if you know your average velocity, you can figure out your displacement by just multiplying it times delta t. So there you go.